Alright, so let us now proceed about the different forms of energy. Okay? As we all know that energy is ability to do work. So those things are very important in order to complete a certain task in our daily life activities. And in our overview, we were able to understand the different uses or functions about simple machines and complex machines, which is also very helpful and beneficial in our daily life activities. Now, the mechanical efficiency, how does it work? So it depends the one who performed it. Okay? It depends upon our work, how we deliver, how we perform those tasks in that particular period of time. That is why conversion and transformation of energy from one energy to another forms of energy is very important. It is because of the accuracy, the acceleration, how fast, how slow, how far, and how long. Because when we perform a certain work, no, we have to consider the important factors or components like force and direction or distance. So take note on this, that those things, no, we should know about the different conversion, different forms of energy. So let's move forward. What are the different forms of energy? And what are the various sources coming from those forms in which it can be used by living things or living organisms, especially man and animals, right? So how is it being used? How does an energy being used? First, we are very much familiar about electric energy. No? So what is that electric energy for? It is a form of kinetic energy that has an electric current. Okay? So there is a current flow. If you remember the word positive and negative charges, no? Especially when we use battery. Okay, so there is an alternating current and direct current. So those things helps to carry out the flow of electrons, right? So that's what we call electric energy. Then remember the various sources of electrical energy. So it can be from the waterfalls, running water, water dams, okay, hydropower plants, then coal power plant. So there are various sources that we can get those electrical energy or electricity in common. And you may also notice that electricity, no, in our daily life activities, especially in this modern age, electricity is usually present. Even at home, anywhere we go, no? Because it helps to operate so many things in order to work easier and faster. So to speed up our work as much as we can. Another thing, our home appliances, air conditions, refrigerator, and all those things that we have at home, which is operated or run through direct to the power of electricity. But of course, remember that our electrical energy is not free. Okay? We have our obligation to pay at the end of the month. Okay? It is part on how, okay, to run also, especially for the subsidy from the government. So that's why we have obligation to pay, especially for electrical energy or electricity consumption. okay, each month. Next, chemical energy. So this is an energy that is stored in and released from the bonds between atoms. So what is this chemical energy for? Okay, so this one helps to heat up, okay, especially with our physical body or different types of vehicles. So chemical energy, we can get that one from the food that we eat. So remember that the digestion process releases chemical reactions, and our body from time to time during the absorption of nutrients and digestion, okay, our body heats up and we feel warm. And those activities that we usually perform, doing some certain task, by doing heavy or strenuous sports, playing strenuous sports, then carrying heavy objects, so anything that you can. So that is why this one helps to boost your energy, okay, by means of chemical energy through chemical reactions coming from the food that you eat, okay. So another point, we have nuclear energy. So in nuclear energy, this is the energy stored and released from the nucleus of an atom by nuclear fission and nuclear fusion. So the nuclear energy, remember, this one also is a great source of electricity too. Okay, some other countries probably they used to take this as part of their economic volume. No? So this one helps to boost the presence of electricity as well. No? And the entire community will benefit, no, out from this kind of energy. So the nuclear energy can be used for warfares, okay, and even the atomic fusion, no, especially for chemical laboratories, okay, and other companies. They might also use the nuclear energy, which is stored from the nucleus of an atom. So another point that we have to remember is thermal energy. So thermal energy, that's coming from the word heat. So thermal means heat. It is an energy which sum up the kinetic energy and potential energy. That is why from colder areas to hotter areas, okay? So that thermal energy is very useful, especially in our cooking activities, no? Burning of objects, what else? To heat up our cars and vehicles in order that the fuel, okay, will be fully functional. And of course, the engine of our cars will fully be functional or operated. So this one, those particles that make up an object to move, to work, okay? So we need to warm up something, especially with our engine of our motorcycles or cars, or big machineries in manufacturing companies, okay? So those are the important points that we have to remember about thermal energy. Next one, sound energy, okay? Every time you hear music, no? Sounds coming from our surroundings, natural surroundings, sounds from the animals, okay? Your singing voices, no? The sounds coming from the noisy people around us, sounds coming from different tools and equipment. So those are parts of sound energy that carried out sound waves, no? In order that we can hear those things properly, okay, going to our ears, and we understand and interpret the things, what's going on around us, okay, and we were able to understand, no? Especially with communicating someone during conversation thing. Okay, if you listen very well, means to say that you adapt, you embrace the sounds that you are hearing with. Alright? So that's what we call by means of sound waves, no? For the sound energy. Another one is seismic energy. This is the impact of the Earth's ground. No? So seismic energy is the energy transferred by waves by moving through the ground. Okay? So this another form of energy usually being detected. No? There is what we call seismograph to detect the volcanic reactions, eruptions, and earthquake. Okay? Through this kind of energy, they were able to be detected, okay, by some equipment in order to check the magnitude, the frequency of sounds in sometimes in natural disasters like earthquake, tsunamis, or volcanic eruptions. Okay, so this normally happens on the ground. Okay, so another thing, electrons move around the nucleus of an atom, and they can move from one atom to another. Now take note that when electrons move, they have kinetic energy and create an electric current. So the energy that an electric current carries out is a form of kinetic energy. That's what we call electrical energy. So always remember, in electrical energy, the important component of charges, those are the positive and negative charges, or positive and negative terminal. So once electron enters, one electron flies to the next atom. Okay? Then electrons continue to fly on by reaching the positive to negative terminal, or for the conventional current, or it could be a current flow. Alright? So chemical energy is that we stored and release from the bonds between atoms. Most electric energy in the United States, for example, comes from fossil fuels such as petroleum, natural gas, and coal. So the atoms make up these fossil fuels joined by chemical bonding. So when fossil fuel burns, the chemical bonding between the two atoms make up the fossil fuel break apart. So when this happens, chemical energy transforms to thermal energy. So what about the drawback? The drawback of fossil fuel is that they introduce harmful waste products such as sulfur dioxide and carbon dioxide too in our environment. So that is why we have to be more aware, no, about the different pollutants or different pollutions, especially air pollutions, water pollutions, land pollution, or soil pollutions. Okay? So scientists are searching for replacement of fuels that do not harm the environment. Chemical energy also stored in the foods that we eat. Our body converts the energy stored in a chemical band in food into the kinetic energy of our moving muscles and into electrical energy that sends signal through our nerves to our brain. So therefore, the majority of energy on Earth comes from the sun. So there is what we call electrical fusion and free neutrons of energy through radiation or radiant energy. So the nuclear fusion, a process found in the sun, joins the nuclei of atoms and releases large amount of energy. So the nuclear energy plants break apart the nuclei of certain atoms using process called nuclear fission. Nuclear fission produces large amount of energy from just a small amount of fuel, especially in a nuclear power plant. Thermal energy is the sum of the kinetic energy and potential energy of the particles that make up an object. So individual particles vibrate back and forth in the place, giving them kinetic energy. So therefore, the particles also have potential energy because of the distance between particles and the charge of those particles. So it started from high temperature to lower temperature. So the thermal energy, temperature is related to the average kinetic energy of the particles in a substance. The atoms in an object are in constant motion. So, for example, when the horseshoe is hot, the particles in it move very quickly. When the horseshoe is cold, its particles are moving more slowly. So therefore, the particles in Earth's interior contain great amount of thermal energy, especially the Earth's ground, due to direct heat from the sun. Okay? So this energy called geothermal energy or ground's earth heat. So geothermal energy plants turn water into steam, which turns turbines in electric generator that converts the geothermal energy to electric energy. So waves are disturbances from carrying energy from one place to another. Then sound energy, it carries by sound waves. Some animals, such as bats, emit sound waves to find their prey during nocturnal activity. So the kinetic energy of tectonic plate movement is carried through the ground by seismic waves.